Computers are everywhere. They are in our homes, our pockets, and even our cars. But have you ever stopped to think about where these amazing machines came from? How did we go from simple counting tools to devices that can process information at lightning speed? Join us on a journey through time as we explore the history, evolution, and impact of computers. We will uncover the stories of the brilliant minds who dared to dream of a world transformed by technology. From the earliest attempts to automate calculations to the development of the internet, it has been an incredible ride. We will delve into the inner workings of computers, understanding the language they speak and the components that make them tick. We will also examine how computers have revolutionized various industries and aspects of our daily lives. The story of the computer is not just about the past, it is a story that is still being written. As we stand on the cusp of new technological advancements, we will explore the exciting possibilities that lie ahead. Artificial intelligence, quantum computing, and the Internet of Things are poised to reshape our world in ways we can only begin to imagine. This journey through time is an invitation to appreciate the profound impact computers have had on our lives. It is also a call to ponder the endless possibilities that lie ahead as we continue to innovate and explore the frontiers of computing technology. The story of computing begins long before the first electronic computer. Humans have always sought ways to make calculations easier and more efficient. One of the earliest and most significant inventions was the abacus. Developed thousands of years ago, the abacus is a simple counting device that uses beads or stones moved along rods to represent numbers. It allowed merchants and mathematicians to perform basic arithmetic operations with remarkable speed and accuracy. Centuries later, the desire for more complex calculations led to the development of mechanical calculators. In the 17th century, mathematicians like Blaise Pascal and Gottfried Wilhelm Leibniz created devices that could perform addition, subtraction, multiplication, and division. These early machines laid the groundwork for the development of more sophisticated computing devices. A pivotal figure in the history of computing is Charles Babbage. In the 19th century, Babbage conceived of the analytical engine, a mechanical general-purpose computer considered to be the forerunner of modern computers. Although never fully built in his lifetime due to technological limitations, Babbage's designs and concepts laid the foundation for the future of computing. His visionary ideas influenced generations of inventors and mathematicians. The 20th century witnessed a dramatic acceleration in the development of computers. The invention of the vacuum tube in the early 1900s paved the way for the first electronic computers. These behemoths, such as the ENIAC, Electronic Numerical Integrator and Computer, were massive machines that occupied entire rooms. They used thousands of vacuum tubes to perform calculations and were primarily used for military and scientific purposes. The invention of the transistor in 1947 revolutionized the world of computing. Transistors were smaller, faster, more reliable, and more energy efficient than vacuum tubes. This breakthrough led to a dramatic decrease in the size and cost of computers, making them accessible to a wider range of users. The development of the integrated circuit, IC, in the late 1950s further miniaturized computers. An IC packs a large number of transistors and other electronic components onto a single chip of semiconductor material, typically silicon. This innovation led to the creation of microprocessors in the early 1970s. The microprocessor, often called the brain of a computer, is a single chip that contains the central processing unit, CPU. The invention of the microprocessor was a pivotal moment in computing history, ushering in the era of personal computers. Companies like Apple and IBM introduced personal computers that were affordable and accessible to individuals, revolutionizing the way people interacted with technology. The miniaturization of computers continues to this day. Moore's Law, named after Intel co-founder Gordon Moore, observed that the number of transistors on a microchip doubles approximately every 2 years. This trend has held true for several decades, leading to exponential growth in computing power and a corresponding decrease in size and cost. Section 4. The language of ones and zeros. At their core, computers understand only one language, binary code. This system of representing information using only 2 digits, 0 and 1, forms the foundation of how computers process and store data. Each 0 or 1 represents a single bit, the smallest unit of information in a computer. Binary code might seem simplistic, but it is incredibly versatile. By combining bits into groups, computers can represent letters, numbers, symbols, images, sounds, and even complex instructions. These instructions, known as software, tell the computer what to do. The Central Processing Unit, or CPU, is the heart of a computer, responsible for executing instructions and performing calculations. It fetches instructions from memory, decodes them, and then carries them out. The CPU operates at incredible speeds measured in gigahertz, meaning billions of cycles per second. Modern CPUs are incredibly complex, containing billions of transistors that work together to process information. They use a system of logic gates which perform basic logical operations on binary inputs to execute instructions. These operations include AND, OR, NOT, and XOR, which form the building blocks of all computer logic. Section 5. Hardware and Software, a powerful partnership. Computers rely on the seamless interaction of hardware and software to function. Hardware refers to the physical components of a computer, such as the motherboard, CPU, memory, hard drive, and peripherals like the keyboard, mouse, and monitor. Software, on the other hand, encompasses the instructions that tell the hardware what to do. The operating system, or OS, is a crucial piece of software that acts as the intermediary between the hardware and the user. The OS manages the computer's resources, provides a user interface, and allows users to interact with the hardware and run applications. Popular operating systems include Microsoft Windows, Apple macOS, and Linux. Applications or apps are software programs that perform specific tasks or functions. Examples include word processors, web browsers, games, and productivity tools. Applications interact with the operating system to access hardware resources and perform their designated functions. The relationship between hardware and software is symbiotic. Hardware provides the physical capabilities, while software unlocks its potential and directs its actions. The constant evolution of both hardware and software has driven the incredible progress in computing technology, leading to ever more powerful, versatile, and user-friendly devices. Section 6. The dawn of the digital age. The invention of the internet in the late 20th century marked a profound shift in how we communicate and access information. What began as a research project funded by the U.S. Department of Defense evolved into a global network connecting billions of computers worldwide. The internet has become an integral part of our lives, transforming the way we work, learn, shop, socialize, and consume entertainment. A key milestone in the development of the internet was the invention of the World Wide Web by Tim Berners-Lee in 1989. The WW provided a user-friendly way to access and share information over the internet. It introduced concepts like web pages, hyperlinks, and web browsers, making the internet accessible to a wider audience. The internet has democratized information, making vast amounts of knowledge available to anyone with an internet connection. It has also fostered global communication, connecting people from all corners of the world through email, instant messaging, social media, and video conferencing. The internet has become a powerful tool for education, commerce, entertainment, and social change. However, the internet also presents challenges. Issues like online privacy, cybersecurity, misinformation, and the digital divide require careful consideration and solutions to ensure that the internet remains a force for good.